Hello, good morning. I am SEEMA GARG, Associate Professor in Chemistry, SPC Government College, Ajmer. Video 80, Lecture 18. It is for B.Sc Part 1, Organic Chemistry, Paper 2. Alkanes, General Chemical Properties of Alkanes. Alkanes are a rather unreactive class of compounds. At room and moderate temperatures, they are quite stable towards most of the chemical reagents such as acids, alkalis, oxidizing agents, reducing agents, etc. And due to this reason, they are also known as paraffins. The relative inertness of alkanes is due to the following two reasons. Alkanes are made up of only carbon, hydrogen and carbon-carbon sigma bonds, which are non-polar since the electronegativities of carbon 2.5 and hydrogen having 2.1 do not differ appreciably. मीन्स उनकी जो इलेक्ट्रॉन नेगेटिविटी डिफरेंस है बहुत कम है. देखिए कार्बन का 2.5 है और हाइड्रोजन का 2.1 है. तो इस कारण से इनकी जो इलेक्ट्रोनेगेटिविटी में डिफरेंस कम होने की वजह से और सिग्मा बॉन्ड होने की वजह से ये जो मॉलिक्यूल्स हैं आल्केन वो नॉन पोलर होते हैं, पोलैरिटी नहीं होती. Thus alkanes are non polar molecules. As a result, polar and ionic reagents, acids, alkalis, etc., find no reaction sites in alkane molecules. Both carbon-carbon and carbon-hydrogen bonds are quite strong. Therefore, collisions of the alkane molecules with almost all the reagent at room temperature do not provide sufficient energy to break these bonds. However, at higher temperature or in the presence of UV light, these collisions provide sufficient energy to break these bonds, but only homolytically to produce free radicals. As a result, at high temperatures or in the presence of UV light, alkanes undergo free radical reactions. The free radical reactions in principle can be either addition or substitution. Since alkanes do not contain double or triple bonds, only type of reactions which alkanes undergo are free radical substitution reactions. So this type of substitution reactions, it will provide isomerism reaction. Isomerization means it will form, we can convert into their isomers. Alkylation reaction, cracking or fragmentation reaction, aromatization or reforming reaction, oxidation reaction. So this type of reactions alkanes are giving. The halogenation of alkanes occur by a free radical mechanism. See here, substitution, it is a free radical substitution reaction. So in first step, suppose we are doing chlorination. Then chlorine molecule in presence of UV light, first it will convert into chloride free radical, and this chloride free radical react with alkane and it will abstract one proton and it will form hydrogen halide. And this methyl free radical will react with another molecule of chlorine in presence of UV light. It will form methyl chloride and chloride free radical. See here, methyl chloride. And this methyl chloride again do substitution reaction and it will form further products. In termination steps, they are combined and form neutral molecules. Similarly, alkane can react with nitric acid in presence of higher temperature or UV light. It will form nitroalkanes and alkane sulfonic acid, and it will react with oleum SO3. Chlorosulfonic acid with chlorosulfonic acid, it will form alkyl sulfonyl chloride. So these all reactions are substitution reactions, and their reactivity is the tertiary is more reactive compared to secondary than primary. Thermal decomposition, pyrolysis or cracking. Suppose normal octane is there. On pyrolysis, it will give different type of fragments, means carbon-carbon bond is breaking. It depends on what type of catalyst we are using. Thermal decomposition of alkanes resulting in the formation of alkenes, fission of carbon-hydrogen bonds is catalyzed by the oxides of chromium, vanadium, molybdenum, whereas carbon-carbon bonds are break by using silica, alumina, zinc oxide, etc. Catalytic cracking of complex high boiling alkanes is employed for the production of petrol from heavy oil. So it is a very useful reaction, pyrolysis and cracking. It is used in the petroleum industry. Isomerization. Isomerization is also used in the petroleum industry. The process of conversion of a compound into its isomer is called isomerization. Suppose normal butane is there. In presence of anhydrous aluminum chloride, we can convert it into isobutane. Similarly, normal hexane, it can convert with aluminum chloride to 2-methyl pentane. This reaction is again useful for increasing the octane number of a petroleum fraction. See here, it is because I am going to discuss about the octane number. So this reaction is useful in petroleum industry to increase the octane number. See here, I am going to tell you. Normal heptane having 0 octane number. So there is no knocking properties. But when it is converted into branching isooctane, trimethyl butane, octane number is 124. So to improve the quality of petrol or to improve the octane number, so this reaction is very useful to convert into branching alkylation. The process of introducing an alkyl group in place of a hydrogen of a molecule is known as alkylation. Isobutane to methyl propene. So we can convert it into with reaction alkylation 2,4,4 trimethyl pentane. The above reaction is used for artificial production of petrol or for improving the quality of petrol. So this molecule having octane number is 124. Reaction with ketones. Isobutane, when it is reacted with acetone ketone, it will form this type of 2,3,3 trimethylbutanol 2. Aromatization. Alkanes containing 6 or more carbon atoms when heated under pressure in presence of chromic acid, catalyst supported on aluminum oxide, give benzene and homologous of benzene aromatic compounds. In place of chromic oxide, we can use vanadium pentoxide, molybdenum oxide also we can use. So normal hexane, we can convert it into benzene in this condition. Chromic oxide, 600 degree centigrade temperature, 15 atmospheric pressure. Similarly, normal heptane gives toluene or methyl benzene oxidation. Ethane on oxidation convention means complete decomposition into carbon dioxide and water molecule. It is an exothermic reaction and it will form about 736 kilocalorie energy. Incomplete oxidation, partial combustion of alkanes in limited supply of air results in the formation of carbon known as a lamp black. जैसा कि हमें देखने को मिलता है घर में, कई बार आप देखते हैं कि गैस सही ढंग से नहीं चलती होती है तो ब्लैक होने लगता है. कैटालिटिक ऑक्सीडेशन, methane when oxidized in presence of copper, 400 degree centigrade temperature, 200 atmosphere pressure, it can convert it into methanol, and this methanol on further oxidation it will give formaldehyde, and formaldehyde on further oxidation will give formic acid. Chemical oxidation, this isobutane when reacted with dilute caminophore, it will converted into tertiary alcohol. So this all about the chemical reactions of alkanes. Thank you very much.